guys, today we're going to look at the topic of shapes in our covalent bonding theory, okay? Particularly, the name of this particular technical name is the VSEPR theory, right? And it stands for valence shell, okay, valence shell, okay, V and S, electron, K pair. Alright, that's E and P, and R stands for repulsion. Okay? Alright, so valence shell, electron pair, repulsion theory. Now we know what valence shells are, right? We know what electrons are, okay? And we know what repulsion is, right? Because we know that like charges repel. I keep saying it over and over and over again. Chemistry is foundational. In order for us, right, to understand the basic shape that we need to know, we have to be able, guys, to draw the structures, all right? And in order to draw the structures, you have to understand the structure of the atom. You have to know what the valence shells are, okay? You have to know what the inner shells are, okay? And so on, okay? You have to know what a covalent bond is from a ionic bond. Because once again, they can give you a question, right, saying draw the Lewis dot structure for this compound, and if you don't know if it's ionic or covalent, you know, it gets bad. Okay, no problem. So, what do we need? In terms of shapes, right, we need a couple of things. We need to look at the valence electrons in the outermost shell, okay? Extremely important, all right. Next, we need to look at something called the central atom, all righty? Now, we agreed before in the other video when we drawn these structures, right, the covalent dot structures, right? That the central atom is the guy that makes, all right, the most bonds. And how do you know that? You have to know the building code, okay? And we agreed in the building code, right? If you're a hydrogen or you're in group 17, I'm just doing some recapping, you're going to form one bond, all right? If you're in group 16, you're going to form two bonds, because we don't want to go to try and draw stuff and make the shapes and we don't know the building code, okay? It's like building a house and you don't have a blueprint, all right? Now, okay, so if you're in group 15, okay, you're going to form 3 bonds, and if you're in group 14, you're going to form 4 bonds, all right? Okay, so knowing this, knowing how many valence electrons we got, and knowing who's the central atom is going to help us immensely. But there's one more important factor that we need to know, guys. We need to know shared pairs and, okay, we need to know unshared pairs. All right? That's also very important. Shared pairs and unshared pairs, okay? Especially unshared pairs that are related to the central atom, okay? Because that's going to affect our shape also, okay? The unshared pairs on the central atom. Sometimes the unshared pairs are called lone pairs, okay? Because they're by themselves, okay? They're not hooked up to another element. They're just by themselves, but we'll express that when we do our examples in a second. Okay, so let's start over here. Ready? All right, Ben. Now, we drew these guys already, right? So today, we're just going to go over the shapes. Now, you're responsible in the regions, right? You're responsible for 4 shapes. When you guys get to college, much more. And you'll see that those ones you do in college, many of them do not follow the octet rule. That's just how it is, okay? But on regions level, we keep it kind of simple. The structures that we draw follow the octet rule. So it's not, there's no surprises, right? But once again, you have to know the basics in terms of what we just discussed. So, as always, guys, you're gonna have your reference table, right? So hydrogen, right? Okay, has how many valence electrons? Has only 1 valence electron, right? I put a little X there. Now chlorine, group 17, has 7 valence electrons. Now, as we agreed before many times, right? The majority of the guys are trying to get to a stable octet. Hydrogen is trying to get to a duet. Okay, he's trying to be like helium, but most of the guys are trying to get to a stable octet. Alrighty, no problem. So, with the 7 valence shape, guys, very simple. If you can draw an imaginary line through all the atoms in the compound, that shape is called linear. All right, how I like to memorize it is line through everything is linear. Okay, done. Moving to the next guy. Next guy is water. Okay, now here's our choice. We can draw water like this, right? One valence electron, oxygen, that's 6 valence electrons, okay? And 1 valence electron for hydrogen, and we can put one there and one there. So that's 4, 6 for oxygen, and 1 for the hydrogen, right? And we can link them up, bam, and bam. But one thing we have to realize, right? This would be incorrect, okay? Now, reason being, in the valence shell electron pair repulsion theory, right? We have the fact that electron pairs, okay, want to be as far apart from each other as possible. Okay, so let's give you a quick analogy right here. Let's say I have these two balloons, right? And I'm trying to squish them together. Goodness, you see that? Yeah. Oh my goodness. It's the electron cloud in action right there. Imagine these are electron clouds, right? I'm trying to squash them together. I'm getting repulsion. They prefer to be like this, guys, away from each other. Okay? No problem. So that's once again. In this theory, all right, electron pairs want to be far apart away from each other as possible, so you're not going to draw them all squashed together. And also, something that we also make a big note of is that unshared pairs, right, have a larger, alrighty, electron cloud, alrighty, than, you see that? Shared pairs. Now, I want you to put an exclamation point around this right here. Unshared pairs have a larger electron cloud than shared pairs. So, these unshared pairs, right, and normally in chemistry, you sort of kind of draw them together, right? So you put the oxygen in your central atom. It's a central atom because why? It makes 2 bonds, hydrogen only makes 1. So by default, oxygen's the winner, he gets to be in the center, okay? Now there's 2 unshared pairs, we put them sort of kind of together, like that, okay? Now what are they doing? They are repelling the shared pairs. So the shared pairs will be like this, okay? More in the down position, okay? Bam and bam. So this is more realistic for the shape of water, folks, all right? Now, you have an imaginary cloud right here, folks. The cloud is there, but we don't draw it when we draw our structures. But just imagine a large cloud of negative charge pushing these guys down, repelling these guys away. Think of this cloud as kind of stretched out because of the difference in electronegativities and tug of war, okay? Now, these guys right here, they're not stretched out, they're bulkier, right? And they're pushing these guys, these arms, down, okay? So this particular shape right here is called a bent shape, B-E-N-T. All right, it's a bent shape. Hopefully you guys can see that. Okay, no problem. So we got 2 shapes. We got linear and we got bent. So if you have 3 atoms and there's 2 unshared pairs on the central atom, it's going to be bent. You have to take the unshared pairs into consideration. That's why it's important to know your definitions, all right? If there are 2 different atoms linking up electrons, that's called a shared pair. If the electrons are by themselves, okay, that's called an unshared pair, okay? No problem. Here we have bent. Next guy. Now we have NF3 over there, right? Okay. Closer. Nitrogen. Group 15, okay? 5 valence electrons. He wants to make 3 bonds to get to a stable octet, right? So we go bam, bam, unshared pair, bam, 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 okay? So, you have 3 fluorines that we're gonna link up, right? Fluorine has 7 valence electrons. Now guys, when you're starting to draw your structures, please show all your dots, folks. Show all your dots and everything, all right? Don't assume, don't take anything for granted, don't take shortcuts. show all your dots. Okay. Alrighty. So what happens here? This links up here. This links up here. This links up here. Okay. Now this unshared pair causes the arms to be pushed down. This shape is called trigonal. All right. Trigonal pyramidal. All right. Okay. And you're done. The last shape. CCl4. Carbon in the middle. 1, 2, 3, 4 valence electrons. 4 chlorines. 4 chlorines. 4 chlorines. Right. So 1, 2, 3, 4. Right. You got 7 dots on each chlorine. Okay. As they're winding down. Okay. Put these in there carefully. Bam, 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 bam. 7 dots, group 17, and you link them up. Alrighty? Now remember, you're not going to draw these bonds all squashed together. The electron pairs want to be as far away from each other as possible, and this shape is called tetrahedral. Alright? And you're done. Alright guys, the next video we're going to make, we're going to go over some more of these guys. I'm going to go over bond polarity and molecular polarity. But these are the 4 basic shapes that you need to know. Linear, bent, trigonal pyramidal,